All right, on the wrong slide here. Now we're cooking. We are going to start this last lesson for Unit 6 on evaluating trig functions of any angle. Now, when we're doing this, we're not talking about angles that are inside of triangles. We are talking about angles that are kind of like occurring naturally. So they can be any kind of angle you want to find and it's all related to triangles, but they're not like written as triangles. So I think that's kind of important to just state that we're not doing any overt Pythagorean theorem or anything like that here. But what we're going to do with this lesson today is we're going to show you kind of a technique of how to identify the angle and what to call it as far as its measure and everything, and then how to evaluate its trig function using that identifying marker, and then some little things we'll do along with that. So we're going to talk about things called reference angles, and then we'll use that to find our 6 trig functions. All right, so a really quick reminder of our functions, all right, is that we've got, you've got your basic SOHCAHTOA, which I think most of us have been pretty good on, right? We've been using those pretty regularly. So you have your sine, let's fix this. You have your sine, which is your opposite, right? Over your hypotenuse, you have your cosine, which was the adjacent over the hypotenuse, and then your tangent, which is effectively sine over cosine, but because your hypotenuses cancel, it's opposite over adjacent. That's how we look at it. And then your remaining 3 functions are basically your reciprocal functions. So when you take cosecant is what you get when you take sine and you flip it, right? So it's hypotenuse over your opposite side, and then secant is what you get when you take cosine and you flip it. So it's your hypotenuse over your adjacent angle, and then your cotangent is kind of an easier one to remember, which is adjacent over opposite. Cotangent's easy because it sounds like tangent. You can flip it. And cosecant and secant are the way I remind myself of those is they go sort of, in my mind, they go along with like the opposite function. I think they should. I think cosecant should go along with cosine because it kind of sounds the same and they both start with the letter C, but it actually goes with sine. And secant, to me, sounds like it should go more with sine because they both start with the letter S, but it doesn't. It goes with cosine. So if you can kind of think of that as like sort of a little switcheroo, then I think that helps. All right. So these are the 6 functions we're going to be doing. That's our quick little review on that. And then now we're going to talk about things called reference angles. So a reference angle is acute. Now remember, acute means less than 90 degrees, right? It's an acute angle formed by the terminal side of an angle in standard position and the x-axis. So the big thing is it's the angle between the terminal side and the x-axis. Those are the big words we need to know there, right? Terminal side and x-axis. So when you talk about something in quadrant 1, it's pretty straightforward and it makes sense to where our brains go is that our reference angle is this angle right here. So from the initial side to the terminal side. So nothing different there. It's exactly what we think it should be. Now, for quadrant 2, all right, we're getting angles that are here that when we're measuring them, right, we're saying, okay, that's going to be this angle right here because you take the terminal side and you're comparing it to the x-axis, not to like how far it's gone. And so this is going to give you the acute angle, right? If you look at this and say, oh, that's 140 degrees. No, we're not interested in that. We're interested in what is it to the x-axis. And so that would be 40 degrees, all right? And now quadrant 3 and quadrant 4 are kind of the same thing. The only thing that's really different about it is just kind of its position and then how we're going to work with that to sort of get it so that we get like signs correct and everything. So it's kind of the exact same thing as you look at it and you say, okay, let's say I went 200 and I don't know, 20 degrees here, right? And if you go 220, what you do is you go, okay, I know it's done a half rotation, so get rid of that 180 from it, which is what this kind of means, right? And then what are you left with? You're left with 40, and then that would be the position here. So you can see what you've got to subtract kind of all the time from this. So like this one, it's taking this and seeing what's the difference between this and 180. This one, you're actually taking 180 away. And then in quadrant 4, it's kind of like what's left here for me to make a full rotation, right? And so to figure that out, it would just be 360 minus whatever your angle is, all right? And then they have this, they use the same kind of thing with radians, right? And here you would use pi radians for these two because you're referencing 180 degrees. And remember, 180 degrees is equal to pi radians, right? That's kind of our converter. And then here you're using 2 pi radians because you're referencing it to 360 degrees, which is 2 of these, right? So 2 times pi, and that's how you get that. So these are what reference angles are. We'll start using these in the next video and kind of talking about them a little more. But that's kind of an introduction to them, and we'll see how they're used in video 2. So we'll see you there.